Hi guys, another video. I'm going to basically take you through my entire setup. I know a lot of people ask when they're starting window cleaning, how do I make pure? For me, I come from an engineering background, so I'm quite handy. I can put things together. I know how to, I know the ins and outs of basic engineering. So it was quite easy for me to translate, but I still had to find the knowledge. I found the knowledge through the internet, I found the knowledge through talking to people, and ultimately I found a big knowledge base on window cleaning forums. I think it's windowcleaningforum.co.uk. I've been on there a lot. The lads are brilliant, they're nice, they'll help you out no end, and ultimately this will probably end up on there because you get a lot of people asking. I was in that boat. This is what I know, and this is where I've got to. So, first and foremost, up here, my apologies if I point something out. I will try and explain what it is, etc., etc. But ultimately, up here is a 15mm speed fit supply from whatever supply you've got. Mine comes directly off an outside tap joint, so it runs up the wall, across into the workshop, along the roof, and in here to here. I've insulated the pipe outside. Don't forget, sub-zero temperatures, they'll freeze your pipe. Getting pipes unfrozen are a nightmare, so take every precaution that you can do to insulate your pipes outside. Insulate your joints, insulate the pipe, tie wrap it on. What you need to do is you need to get a good tight seal so that there's no gaps or anything like that, and it should help against frost protection. If you do get some frozen pipes and you're a bit unsure what to do, ultimately get the wife's hairdryer and blow it down the insulation. Leave it running and it will defrost the pipe so it can get a flow going. You should be alright. So ultimately it comes in up here. 15mm JG speed fit are probably the best plumbing fittings that I've come across. I've used a few other push fits, etc. Don't waste your time. JG speed fit are by far the best. You can get them from Screwfix, you get them from B&Q, you get them from all retailers. You can open them, attach them, detach them. You can sort them out. They're brilliant. I have used ones where when you've put them on, that's it. It's really embedded into the pipe. And if you've not done it correctly, it's a bit useless. You have to throw it away. JG Speed Fit are the best ones. I tend to use 15mm, it's the standard size, and it's equivalent to the half inch BSP. So if you're getting any connectors and you want roughly the 15mm or half inch to speed fit, you're talking 15mm to half inch BSP. So that comes in, and I've got a water pressure gauge. If I've got any links to anything that I mention, because I found a lot of parts cheap, I'll put them in the link down below. Get onto eBay, get onto Amazon, get onto where I found them. If the auctions are still live and stuff like that, they're one of the cheapest that I found, and by far good quality. So I've got a water pressure gauge. Mine statically sits around 40. I don't know if you saw that then, it fluctuated. It will fluctuate because someone's using tap inside. It's bound to do, but mine sits around 40. That's quite important when it comes to your RO membrane. It's going to tell you what you can and can't run, whether you need a booster pump or not. We'll get more onto that later on, but ultimately I would suggest that everyone knows what the pressure is by putting an inline pressure gauge in. $7.99 I think this cost. Free postage off eBay. We'll see if I'm lying. I think it was $7.99, might have been a tenner. Ultimately the link should be down below. That tells me what my pressure is. If there's any abnormalities, I should be able to pick it out. If you look there, that's currently running at 22 because someone is using water in the house. That's what that is. When there's no water being run, it will sit at 40, there or thereabouts. That then leads down to a split. Now I've got this split in so I can drain off or I can run off the tap water. So this locks off. These are 15mm half inch BSP taps from Screwfix. They're a brilliant solid metal construction. I think they cost about $4.99 each. Ultimately, brilliant. I've got them in a lot of places, and that's it. I must mention, further up, I have got one of them taps that's an isolator. So if I need to work on any of these joints pre to it, I can isolate it off there. So ultimately, I have this joint here so I can lock it off from all the filtration system, and I do that for two reasons. One, so I can open this tap. I've got a little drain down here. It's just like a little runoff that runs off into the drain, but this specific pipe runs off into the bowl. You can hear it running. I have this for two reasons. One, it allows me to test the TDS of the water coming in from the tap without it going into the filter system. That way I can run a sample off. What I will do is I'll run a sample off, have a nice handy jar. I know my water at the time was around 330 TDS, something like that, so I've not produced any water. We've had a lot of rain, so I don't know whether that's part and parcel of it. We get our water from a borehole, which is an underground reservoir. Some days it can be 330, like today. Some days it can be 40. So if I don't need to produce water, I'll wait until the TDS is as low as possible and produce it. So what I tend to do is I'll run some off, so anything that's excess in the pipe from the last time I tested it will run off, and then swing it over again. JG Speed Fit joints allow you to do things like this. Run off a sample, turn it off, put it back into the drain off section, clip it back in, get your TDS meter. TDS meter, you won't be able to see it because it won't focus, but at the minute is showing 343. So that's high. I don't want to produce water. What you're aiming for is the lowest possible. So that allows me to do that without even putting it anywhere near my filters, and it's all there in one spot. So I run that off and I can test. Get rid of that water. So what I will do is I will open it purely and simply to show you and evaluate what's going on. Let's lock this off, which is the RO. So ultimately we won't produce anything just yet, but what I'll do is I'll open that. You'll hear the noise that you heard then is the waste from the RO. That's that noise, and it's running through the system. So it then goes through here. When I've unlocked it, when I've tested it, it'll go through here to the solenoid. The solenoid is activated by this float switch, and we'll get further on to that, but ultimately what that does is it sends an electrical signal to say open or shut, this is full. That's it. It stops you having to come in and watch it and turn pipes on. That's what that does. It's a recent addition. I got that off a gentleman on the forum. He sent me some links to the parts from Australia. I don't know why, but I sourced them on Amazon myself, got them. Again, the links will be down below. Source of information on the window cleaning forums was spot on. He even sent me the diagram. I can't remember his exact name, so I can't give him a shout out, but you know who you are. Everyone knows who you are, so thank you. It then goes into your pre-filters. Your pre-filters are vital. They're exactly what they say, the pre. They go before, so you've got to have them. This is a triple 20-inch setup. I got this unit with the filters, the hanger and everything. I got that off eBay. I think it was around £50 from Germany. The link will be down below if it's there. It was the cheapest I could find. It's worked spot on. It's brilliant. Does exactly what it says on the tin. You can get 10-inch ones, but I went for the 20-inch ones purely and simply. Capacity's king. That's what I always say. Capacity's king. So it then runs through there. So it runs through a sediment filter, takes out all the dirt. That's always your first one. Your sediment, it looks like a cotton material one. The cartridge looks like a cotton material. That's your sediment filter. That goes in your first one. I've then got two activated carbon ones. That takes out excess, possibly bacteria and bits and pieces. I know it takes the majority of the chlorine out, which can damage your RO membranes. But ultimately, as you're going along the system, the holes and gaps and things like that for pieces to get through are going smaller and smaller, and ultimately that's where you get pure from, because you're taking everything out. It's simple maths. Subtract everything and you get pure. So that again feeds through there. What I can do as well is I can turn that off and I can open another, if I can open another runoff. So straight after that I can test water. For me it's vitally important to be able to monitor water at different parts. If you can't monitor it, how do you know where there's an issue in your system? If there's an issue with your RO membrane, then you'll be able to pick that up when you test that. If you have no test points whatsoever, you're not going to be able to find any. So let me just turn that off because it's making a dreadful noise, and ultimately I'll turn that off. So again, I have test points. I have a test point before, I have a test point after the pre-filter, I have a test point after the ROs, and ultimately, until I'm happy with what's coming out of the ROs, it doesn't go to the resin. You use more resin by sending more dirtier water through. The more pure your water going into the resin, it doesn't dissolve as quick, it doesn't use it up. If you send it through, you'll use your resin up more. So the ultimate aim is to only run things through resin that are as clean as possible, that are as pure as you can get them. So after I've tested that and I'm happy with everything that's coming out of there, it then gets fed into the RO membranes. These RO membranes are 3 30-13 membranes. I got 3 domestic ones purely and simply because they work off the static pressure. The static pressure is just the tap pressure. There's no booster pump. It doesn't need to be boosted up for me. They're designed to work on low pressure. Now this system and these 3 RO membranes can ultimately produce 1,000 litres in this IBC container in around 12 hours. That's perfectly sufficient for my water needs. In fact, I'm sat on water at the minute because I've just started. But ultimately, when rounds get going, when commercial jobs come in, when you're doing more and more and more, your water needs are going to go up. If you're using more than 1,000 litres of water a day as a single window cleaner, you're either doing very, very, very well and working very long hours, or you're just using too much water, I think. Anyway, I've got these. They work perfect for me because they work off static. You can get 40-40 RO membranes, and when you hear these numbers, 30-13, 30-12, 20-20, 40-40, they refer to the length and the diameter of the RO membranes. That's exactly what it is. It's no more complicated. It's what's used to describe it, and it's the size. These ones are 30-13 because it's 13 inches long and it's 3 inches in diameter. You add a 0 to it, so you get 30-13. The 40-40 membranes are 40 inches long and they're 4 inches in diameter. Don't get confused with it. I know it's a bit daunting, but that's exactly what it is. They're just numbers that depict the size. Why did I choose these ones? Well, I basically chose them for the static point, which I've just gone through, but also I can then isolate one. So if one becomes bad, one's not functioning properly, I can simply take it out of the system and continue producing water. The ultimate aim is to be able to produce water whenever we need it and in abundance that we need it. Anything goes down, then it causes headaches. Everyone knows something goes down, needs fixing. Even with Amazon and next day, you're ultimately talking next day minimum before you can get it. You may need water. You may have to then go to a spotless water beg, steal and borrow some. So ultimately downtime is another factor why I got 3. The plus point for me was how cheap they were. Again, if I can find it, the link will be down below, but I think off the top of my head I paid £20 for each housing and £20 for each membrane. So that brings me up to a total of £120. Now, a good 40-40 membrane, you can be looking with the housing and the membrane around £400-500. So for me, it was a no-brainer. Domestic static pressure, changeability and ease of continuing water production if one module fails, and overall cost. If you have a 40-40 RO membrane, unless you're using one of the ultra low pressure membranes, from what I understand, that can work off static pressure but aren't best for them, you need a booster pump. So ultimately, a booster pump will force more water into it, brings the pressure up, makes it work better. They're a good industrial unit and they're a good commercial unit, but for me, ultimately, starting out, these were the ideal situation for me. It then comes, you've got two outlets on your ROs. You've got drain and pure. Pure refers to the good water that's coming out. Waste is obviously all the rubbish that comes out. So if you're ultimately putting in, let's say, 100 TDS into the top, and you're coming out with, should be around 4 or 5 from 100 TDS. If you've got 150 TDS, you know, a good ratio is about 94 to 95%. That would be a good ratio. If you're getting down around the 90, 85 mark, your membrane may need replacing or you may need to tweak something. When you've got your cleaner, your purer water coming out, there's obviously waste. That's going to be concentrated. Again, I monitor that down here. So at every point, I think it's essential to be able to pull off a sample. That I can monitor. You know, you'd expect that to be knocking on door of 300 TDS, because it's a concentrated solution of the impurities that hasn't gone through the membrane. Now it's just out of shot for you here, but I've got an isolator valve there. You'll see them dotted around: isolator, isolator, isolator. The isolators are all over the shop and they're there for a good reason. They're not cheap. I think these are ultimately around £7-8, and there's quite a few of them. The bigger ones, like I said, are about £5. But ultimately, it's about sampling. I say it a lot. You know, I've never known anyone else go on about it so much or mentioned it so much. But for me personally, from an engineering background, I want to know what's going on and where, and if there's any difficulties, where it's happening. So you've got a lot of isolators and connections. You can't see, but this pipe then goes out into a DI resin vessel. In the end, comes out and directly into the IBC container. The IBC container I chose because it's what it's built for. It's built for containing liquids in a pallet-sized thing. It's got a cage. It's good, solid polyethylene, I think, which is the stuff that doesn't crack. It's the stuff that bends and flexes. And it ultimately drops into there. When it's filling up and the water's flowing, the system's working, the float switch, like I said, connected to the servo valve. Basically, there's a little switch inside, and as the water comes up, the float lifts up and it makes the connection. It makes the electrical connection, completes a circuit and shuts that valve. When it drops back down, it goes into its normal mode, which is open and then allows water through. So it's a dead simple thing, but ultimately means you don't have to keep your eye on it. The outlet for me was a dirty water pump. When I say dirty water pump, it wasn't dirty. I like to keep things clean in here, but it was a brand new sump pump. Does 9,000 litres an hour when you use the maximum bore. This was the This was the adapter that came with it. As you can see, got an 1.5 inch here, and it'll go down to probably about 1/2 inch-ish, something like that. If you try to push 9,000 litres an hour through a hose pipe, you're ultimately only going to get about 1,500 litres. That's because the hole isn't big enough. The bigger the hole, the more flow. To get the full flow from this at 9,000 litres, I needed an 1.5 inch, 38mm braided pipe. Got that off eBay. Superb. It was the cheapest I found. Again, the link below. Ultimately, pumps up, out, over the roof and into the van after a switch. What I did find is when I did that, it was a siphon effect. Even when I turned it off, it created a siphon. So I attached a 1/4 inch PVC piping that I use for the RO, put it on there, attached it to the pump, and when I lift that up, it lifts the pump out of the water. It allows air to flow in, stops the suction, and ultimately stops it drawing any water. When I'm finished, drop it back down, and it's done. That pretty much is my setup. That's the basics that I need. If I've got anything wrong, I'm not an expert, I'm just giving information as to what I knew. And if you head over to the windowcleaningforum.co.uk, the guys will help you out no end. They're superb. And that is the basics of purifying water.